All right, so let's look at these multiple choice questions. See what exciting concepts we can reinforce now today. You got 20 minutes, y'all. 20 minutes. You just have like a 5 to 10 minute break as you finished early. Okay, so we're fresh. We're wanting to learn. I can just see it in you. This is what makes the world go around, y'all. This is just. Now, this is classic type question, especially at the beginning of the multiple choice, where they give you groups of questions that deal with just a block of answers. Just a tidbit, test taking. You can always use an answer more than once when they give you the list like that. So question 1, 2, and 3 could all be the same answer. So it's not a matching on that. It's just whichever one's the best one. Okay? So, ethanol. The questions 1 and 2 refer to the following types. Is it a network, molecular, with hydrogen bonding, zero dipole moment, or an ionic solid? Okay, so the good news is right now, hopefully, all of that makes sense to you. Okay, that's the step 1. I just remember when I took the SAT, I was not real good. I didn't like to read a lot. Now, my English was always my low. You know, they give you the vocab, you know, they give you the word, they want either the synonym or the antonym to it. And I didn't know what the word was, and I generally didn't know what any of the synonyms or the antonyms were, you know, anyway, I didn't do very well. Did well in math, but not on the English part. Okay, so, ethanol. First off, is it an ionic compound? Is it a network? No. Okay? So, that means we narrowed it down to B and C right there. So now I got a 50-50 shot. I have an OH on it, so what does that automatically mean? Polar. Dipole moment. Okay? So we can just kind of go right down. Now this one too, that silicon dioxide, we just memorized, so we know this is covalent network. Alright, only way to know that. Questions 3 through 5 refer to the following molecules. Okay? Now, I'm going to tell you that you need to memorize anything and everything about CO2 because they use it in just about every question and whether it's a fake answer or a real answer. Okay, so let's just talk. How is CO2 bonded? 2 double bonds to the oxygen, right? Okay? So, what's the shape? Linear. Is it symmetrical or asymmetrical? Symmetrical. What's the AX formula? What's the shape? Linear. What's the bond angle then? 180. What's the type of hybridization on the carbon? SP. Is it going to be polar or nonpolar? Nonpolar. Because it's symmetrical. So we just, you don't need to write all this out. If you just know CO2 is linear, nonpolar all the time, it just helps you just be able to eliminate. We know water is bent and very polar. Okay? Now these other ones, you might have to actually draw out. But pH 3, when you just do the Lewis dot structure, it looks like that. And C2H4 is a little trickier, but it ends up looking like this. Okay? So I like to know what I'm dealing with before I try to answer the question. But the molecule with only 1 double bond, well, that's got 2 double bonds. Water, I know, doesn't have any. Hydrogen, I know, can't form a double bond. Okay? And that's all that has. So I memorized CO2. So I know it has 2 double bonds. Hydrogens can only form single bonds. Therefore, it's got to be this one with the 1 double bond. The molecule with the largest dipole moment. What does that mean? Most polar, which is going to be water. Okay? Hydrocarbons basically are nonpolar. Doesn't have a phone call in it at all. Matter of fact, hydrogen's electronegativity is 2.2, phosphorus is 2.19. So there's only a difference of 0.01. So this is very, very nonpolar. Okay? Linear is nonpolar. Water is going to be the most polar. Molecule that has trigonal pyramidal shape. What's the AX formula going to be on that? AX3E. Okay? pH3 is the only one that's going to do that. And you'll find that pH3, NH3, those are all going to be the same in the same family. So we need to be able to draw the Lewis structure. We need to know the shapes. Now again, on the AP test, you don't have the cheat sheet. So that's why we have to just know those. Then the geometry of an SO3 molecule. Now we did this as an example. SO3 has 18, 24 electrons, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So what do I need? On which oxygen? And it doesn't matter. So what phenomenon occurs in this molecule? Resonance, okay? So I can put the double bond there. Now to answer this question, I don't need to know anything about resonance. What's my AX formula? AX3. That's not an answer. But so what is shape is AX3? Trigonal planar. Okay? Trigonal planar. 3 electron pair domains, 3 places for electrons, 3 sigma bonds. Okay? Now, if I was to draw my resonance structures, I'm going to go sulfur here. Okay? Double arrow, and I'm going to put the double bond here. So what do I know about all 3 of these oxygen to sulfur bonds? Are they the same or different? They're all the same. There's not a single bond, there's not a double bond. What's the bond order going to be? About 1 1/3, somewhere in that range. Okay? Stronger than a single, but weaker than a double. So we'd have resonance structure going on there. Now this is another one that we could do formal charge on. This was the example that we did formal charge. And in the formal charge, it ended up making it like this. Okay, this is according to minimized formal charge. Okay, so good example in SO3, the non-trigonal planar, resonance, bond order, formal charge can all be SO3. Shortest bond length. What's going to determine the bond length? What size, okay, or the number of bonds, the bond order. Okay, I would look at bond order first. Okay? How do we know nitrogen's bonded? Triple bond. Oxygen, double bond chlorine, single bond, but then they put in bromine. Okay? Notice that bromine is way down here. We have the nitrogen, oxygen, chlorine, single bond, and then bromine. Okay, so this one's tricky because I want to say the shortest, well, no, I want the shortest bond length, so it's not tricky. If I want, obviously the longest bond length is going to be the BR2. Shortest bond length is going to be the small triple bond nitrogen. Okay? Explain.
Yes.
Just pour me.
I didn't think about it. I didn't think about it. I poured in nitrogen. He poured in oxygen. And we went with it.
Well, that's why you're supposed to do your own work.
Dang.
Very something about it. Said,
All right,
Tomorrow after all this time, I think.
pi bonding. Pi bonding is involved in what type of bonds? Double bonds. So we know CO2, does it have pi bonds?
yes.
Yes. Can hydrogen form a pi bond? No, so that's automatically my answer. Okay? CN minus. Okay, CN minus, just so you know, the cyanide ion always kind of looks like this. It's like that. Okay? That's the cyanide, and so HCN, you just put an H over here and it gets rid of the charge. But cyanide, carbon, nitrogen, that's a triple bond there, so you're going to have pi bonds. C6H6, anybody remember which one that is? That's benzene. Remember we did the benzene ring? With the circle and implying resonance, that we have alternating double bonds. Another kind of good one just to kind of know, this is good example for resonance. Okay, so maybe write on your sheet out there, watch for resonance or exhibits resonance. Okay? Maybe on the opposite side, the cyanide, draw that it's the triple bond, CN, triple bond, draw this out there just so you can just get familiar with it. These are just common examples. All right, which has a zero dipole moment, meaning again, which one is not polar? HCN, is that going to be symmetrical or asymmetrical? So there, and it's got a nitrogen, so it's polar. NH3, again, AX3, asymmetrical, polar. SO2, and when we draw it, it's bent, asymmetrical, it's got oxygens, it's going to be polar. PF5, though, has a symmetrical trigonal bipyramidal shape, so it is nonpolar because it's symmetrical. Now that one takes some time because you probably need to draw the Lewis structure for each of those to see the symmetry. However, HCN, you know carbon's going to be the central atom, so you can see that it's not symmetrical. This is, and what's the common name of NH3? Ammonia. Okay? Again, that forms hydrogen bonds with water. It's got the hydrogen attached to the nitrogen, so we know it's going to be very polar. Okay? Sulfur and oxygen, this one you just need to know it's bent. Because if it was linear, it would be nonpolar. This one you just got to know AX2E. I would just draw it out. And then the PF5, well, again, you draw that just to make sure there are no lone pair on the central atom. This one you just got to pretty much draw the Lewis structures and figure it out from your shapes and your symmetry. All right, home stretch. Resonance. Is hydrogen ever going to have a double bond? No, so I know that's not in here. CO2 we've memorized. Does it have resonance possibilities? No. Okay? Does fluorine form double bonds? No. This is the off molecule. I call it the main ingredient in mosquito repellent. It's not really, but it would be good if it was.
Oh, I get it.
Off, OFF.
I believe it's allergy.
Okay, but halogens don't form double bonds. Now, I just drew it over here somewhere. SO2. SO2 is going to look like this. So it's going to be bent, but we can have a choice on where the double bond goes. But we're only going to have two choices on this one. It's going to be this one and yeah, that one's close enough. So what's the bond order of the oxygen to sulfur bonds there? 1.5. Okay? The Lewis structure, which of the following shows only one unshared pair of valence electrons? What's another name for an unshared pair? A lone pair, okay? Well, hopefully some of these, I mean, you can kind of just figure out. CCl4, it's going to have 4 things around the carbon, so it's not going to have any. Ammonia, we've done a bunch of times, that's your answer. It's got 1 lone pair. Nitrogen is going to be the triple bonded to nitrogen, but each one is going to have that. Chlorine, each one is going to have the 3 lone pair around it. Okay, but ammonia, going to look like that, and then CCl4. If you're familiar with ammonia, a common compound, you just know that structure, and that, I mean, you know it's only got one lone pair of electrons, therefore, it's your answer. All right, so what are you bringing to class tomorrow? Tomorrow is the next time we meet. I really don't think about when tomorrow is. As much as I'm enjoying that today is Friday, when I'm thinking about the next time we meet, I'm just thinking tomorrow. All right, you have 5 minutes to study.